Hello everyone, I am Jinwoo Hwang. I have the privilege of serving as the lead developer, project lead, and release manager for the Apache Geode 2.0 project. Today, I'm thrilled to walk you through something big, Apache Geode 2.0. This release represents one of the most significant modernization efforts in the entire history of the project. It's a major step forward, a true evolution, and a transformation designed to bring Geode in line with today's Java Enterprise standard, while also ensuring its long-term sustainability. So let's dive in, because there's a lot to share and even more to look forward to. Let me explain why I work on Apache Geode project. I don't make a single dime from the sleepless nights or weekends I poured into Apache Geode project. I truly appreciate the SAS Institute, my current employer, for giving me the opportunity to contribute to the Apache Geode project. That said, contributing to Apache Geode doesn't mean my regular workload gets any lighter. I still carry the same responsibilities while making time for this project. This is simply because I love what I do, for the community I believe in, and the legacy we are building together. It's not about compensation, it's about conviction, contribution, and the joy of seeing something meaningful thrive. I know it's a cliche, the quote, "He who has a why to live can bear almost anyhow." In the German philosopher Friedrich Nietzsche's 1888 work, Twilight of the Idols, says it all. A strong sense of purpose provides a strength to overcome any difficulty or obstacle. The idea has been influential, notably in the work of an Austrian neurologist, psychiatrist, and Holocaust survivor, Viktor Frankl. His logotherapy is built upon the idea that people are driven by a search for meaning, as it was viscerally evident in his memoir and psychological work, Man's Search for Meaning. Okay, enough of philosophy, right? Let me introduce you the project and share my story of the journey to the Apache Geode Release 2.0. Alright, let me briefly explain what Apache Geode is for those who are not familiar with the technology, because this platform does some seriously impressive things. Apache Geode is a distributed in-memory data management platform that provides low latency, scalable, and consistent data access to high-performance applications. What does that mean in English? Picture this. You've got applications that needs to react instantly. Data flying in from everywhere. Users expecting real-time results, and you need to make all of this work not just on one machine, but across dozens or even hundreds, even maybe geographically separated clusters. Apache Geode features dynamic replication, smart partitioning, and always-on fault tolerance. It spreads data across multiple servers for scale, keeps copies around for reliability, and stays alive even when nodes fail. Geode doesn't blink. Your system stays up, period. That's exactly what Apache Geode steps in. The architecture of Apache Geode is pretty straightforward. You've got distributed cache servers that hold your data in either partitioned or replicated regions. And then you have locators. Think of them like the GPS for your cache servers. They keep the cluster organized by managing membership and helping discover servers, so everything stays connected and running smoothly. On top of that, Geode supports disk persistence, So even though it's an in-memory system, your data can be safely stored on disk for durability and recovery. And Geode pulls together memory, CPU, and network power from a whole cluster of machines and turns it into one unified, lightning-fast data engine. Your apps get consistent, real-time access to data even when the data is scattered across the cloud. Let's talk about topology of Apache Geode. There are peer-to-peer, client-to-server, and multi-site topology configurations. First, a peer-to-peer configuration. This is the foundation, the building block. In peer-to-peer configuration, every cache member talks directly to every other member. It's the simplest topology, and it's perfect when you want the cache embedded right inside your application. Think of application server cluster where each server runs your app and holds part of the data, sharing the same heap, working together as one. It's tight, fast, and great for co-located workloads. Now here's a client-server configuration. What if you want more scalability, more isolation, or you don't want every application instance to carry the full data load? That's where client-server configuration comes in. Here, clients keep just a small slice of data locally and send the rest of the world to a cluster of servers. The magic? Those servers are themselves a peer-to-peer cluster, so you still get all that distributed goodness, but with a cleaner separation of concerns. Client-server configuration shines when data distribution gets heavy on the network or when you need a big vertical scaling. Clients talk to servers through connected pools. And yes, clients can even maintain a local cache for quick reads. And there's a multi-site configuration. When you need to go big, global, worldwide, Geode supports multi-site configuration. This is a horizontal scaling across the regions. Multiple Geode clusters, loosely coupled, often over slower, wide area LAN links. Why loosely coupled? Because it gives you a better performance across distances, independence between data centers, and the ability for each site to keep functioning even if the others go offline. In a multi-site setup, each individual site is still a peer-to-peer or client-server system, but now they all work together across the map. So what does all this mean? Apache Geode gives you the power to build a real-time, in-memory, fault-tolerant data fabric that scales vertically with the client-server configuration topology, scales horizontally with the multi-site topology, and stays blazing fast with a peer-to-peer at its core. All while your applications enjoy consistent, low latency access to distributed data without even worrying about where the data lives. That's the Apache Geode. That's the engine behind truly high-speed, data-intensive, cloud-scale applications. Now you might be wondering, where did all this start? Well, let's rewind the clock all the way back to year 2002. In 2002, a company called Gemstone Systems introduced GemFire, a commercial, distributed, in-memory data management solution. And guess what? It didn't take long for GemFire to become a star in the financial services world, powering real-time applications like fraud detection, stock trading, and portfolio risk analysis. Now fast forward to 2010. Gemstone Systems was acquired by SpringSource, which was a part of a VMware at the time. Then, in 2013, EMC and the VMware spun up assets into Pivotal Software, and Gemfire went along for the ride. Now here's a big moment, year 2015. The Pivotal open sourced the core of Gemfire under a new name, Geode. Right, that's what we are talking about here, Geode. They proposed it to the Apache Software Foundation, and from that moment on, Apache Geode became the open source sibling of Gemfire, sharing the same DNA. Interestingly, we have a living witness to this history, none other than our own Niall Pemberton, one of our longest serving PMC members, encountered Gemfire during his day job. That experience didn't just stay at work for him, it sparked a passion. Soon, Niall began contributing as a mentor, grew into a committer, and eventually became a PMC member, working on a Gemfire Geode project for 12 years, transforming professional familiarity into lasting impact on the project. He remains one of our most active PMC members, someone widely respected across the entire community. And fun fact, he's basically our unofficial public relations officer. If you ever seen Apache Geode news pop up on social media, there's a good chance it came from him. We appreciate your service, Niall. So, how do we measure the trend of a project like this? Yes, commits. Let's take a look at GitHub commit chart. A quick reminder here, the y-axis shows the number of commits, not necessarily lines of code. Before 2024, commits and code changes were pretty correlated, but in 2025 and beyond, not much. Why? Because of a monster commit, the Jakarta Enterprise Edition migration project, which has over 10,000 additions and around 800 file changes in one shot. Yes, that counts as just one tiny bar on the far right of the chart. Let's go back to timeline. In 2015, we start strong, and contributions are buzzing until 2019, when things did. Was it COVID? Maybe. But the real earthquake? The VMware acquired Pivotal in 2019. Then, in 2022, Broadcom announced the plans to acquire VMware, and that shook everything. In an Apache Geode board meeting that year, it was reported most committers and PMC members, that's Project Management Committee members, had gone inactive. Out of 116 committers and 35 PMC members, only 5 were fully engaged, and another 5 were helping short-term. Pull request and Jira activity almost flatlined. Then came 2023. Broadcom released Gemfire version 10 in April. And the last commit to Apache Geode, it was June 2023. After that, winter sets in. 0 contributions, silence. By 2024, the Project Management Committee voted to terminate the Apache Geode project. It was the end, or it seemed. But there's a twist. 2025, I started committing my fork of Geode back to the community. We shipped version 1.15.2 in September. And now, drumroll, we've announced version 2.0. What a comeback story from a long winter to fresh spring for Apache Geode. It went from being a patient on life support to cruising at light speed. Let me take you on a quick journey. A journey that started with a fork. Not the kind you eat with, but a fork of Apache Geode that I've been maintaining for years on behalf of the SAS Institute, my current employer. Now, Apache Geode is one of the third-party components we rely on in our SAS products. And for a long time, I've been the person responsible for fixing security vulnerabilities, not just in our products, but in Geode itself. Here's the catch. There hadn't been an official Geode since 2022. So every vulnerability, every patch, it was on me in our fork. Fast forward to late 2024, the ground shifted. We are gearing up for a major SAS product release built on Jakarta Enterprise Edition, Java 21, Sublet Specification 6.0, Spring Framework version 6, Spring Security 6, Apache HttpComponent version 5. Sounds exciting, right? Except Apache Geode version 1 supported none of these. 0. And yet, I was expected to deliver a compatible version month before our release date. Oh. And while I was at it, remediate dozens of vulnerabilities in Spring Framework 5, which was already end of life. This wasn't a patch job. This is a tectonic shift, a rewrite of a majority of codebase to align with the modern architectures. The latest Java Enterprise Edition specifications, Sublet 6, the new Spring Security Platform, and a redesigned Spring Framework. And here's the kicker. Everyone else was laser focused on the new SAS product release. So this mission, it was on mine, alone. My journey to Apache 2.0 began last September. Month after month, it was a grind, pressure mounting, deadlines looming, and the weight of responsibility squarely on my shoulders. I'll never forget one night I collapsed on my keyboard. Woke up at 3 in the morning in a puddle of drool. Disgusting, absolutely, but that's how much I poured into this project. And in the end, I made it. I delivered Apache Geode 2.0, not the official version, but a fork tailored for SAS Institute. And because of that, our new SAS product release shipped on time. Happy ending. Here is a snapshot of the CVEs I successfully remediated with the release of Apache Geode 2.0. Delivering this version wasn't just about compatibility, it was about making Apache Geode safe, resilient, and future-ready. I'm so proud to have strengthened its security posture and ensured it remains a robust foundation for our SAS product as well. After we celebrate the SAS 9 release 9, I thought, why keep all this sweat and blood effort locked inside of SAS? So I teamed up with Brian, our open source program manager at SAS, or I'd like to say Dr. Berenshausen. That's when my journey to share this work with the world began. I had already completed the core of Apache Geode that SAS products depended on, but the full project, it was a beast with session management, monitoring, and countless other components. Once again, I volunteered for more than I could chew. It felt like fixing and piloting a TIE fighter to Mars. Only to be told, great job, now take the Millennium Falcon there. 10 grueling months later, I made it, thanks to every pull request reviewer who stuck with me. And if you're still at me, well, I owe you coffee. Apache Geode by numbers. There are more than 11,000 Java classes, and more than 10,000 test cases, and there are 9,000 or more Java files across 32 projects. And this project represents a complete modernization of Apache Geode enterprise Java stack. I've successfully migrated from the legacy Java 8 to Java 17, the Jakarta Enterprise Edition 10 standard, while simultaneously upgrading major framework dependencies like this. JAXB, Spring, Apache HttpComponents, Apache Lucene, Eclipse Jetty, and Java Servlet Specification 6.0, and Application Server Session Management. The impact: over 800 files changed, over 10,000 or more insertions, and affecting hundreds of Java files migrated, and more than 100 command classes updated for Spring Shell, version 3 compatibility. Most importantly, more than 10,000 active tests are passing with 0 compilation errors across all modules. So what do we have in Apache Geode? There are several modules or projects or components in Apache Geode project. The first one is a core, that is the heart of Geode. The web, that's a core web functionality and sublet integration. And we have a Geode Web API that is responsible for REST API interfaces and controllers. And the Web Management module, that's a management REST endpoints, and Pulse, that's a web-based monitoring and management user interface. And Geode GFSH, I call GFish, that's command line shells interface. There are more than 118 command classes, and connectors, that's JDBC and external system integration, and the WAN, that's a wide area network replication module, and Lucene, that's a full text search integration, and the modules, that has a session management module for application servers. Apache Geode 2.0 project has been a marathon, not a sprint. Months were spent wrestling with a Spring 6, Gradle, and Java compatibility. Each upgrade uncovered new blockers and triggered a cascade of changes. The first mission was urgent: fix the security vulnerabilities from Spring 5, which was end of life with no update. So I tried upgrading to Spring 6 and building Geode. And bam! Tens of thousands of compile errors show up. I was shell-shocked, thinking, what have I signed up for? The errors made one thing clear: I also had to upgrade the entire Geode build environment to Java 17. No big deal, right? So I upgraded the build Java from 8 to 17 and ran the build again. I was relieved until I saw only one error, and it didn't even compile. The message said I couldn't use Gradle 6 with Java 17. So okay, I upgraded Gradle from version 6 to 7 and ran the build again. And then build errors and tens of thousands of compile errors show up. At this point, I had created more problems than I started with, and I haven't even touched the Spring Framework upgrade yet. Complete despair. In retrospect, Apache Geode 2.0 was like a stack of domino tiles triggered by a chain reaction. The next challenge was migrating the build system from Gradle 6 to 7. This meant rewriting all the build scripts to use the new syntax and API of Gradle 7. Gradle 6 simply couldn't build with Java 17, which was blocking all progress. So I migrated every build script centralized version management, enabled the configuration cache, and resolved intermodule dependencies. The result? Faster builds, a much smoother developer experience, and a build system ready for future enhancement. Spring Framework 6 and other modern frameworks require Java 17 or higher. Java 8 is end of life and it's missing critical security and performance features. So all modules needed to be compiled and run on Java 17. The codebase was refactored to make advantage of new language features and remove legacy APIs. The impact is clear. Project is now future-proofed for modern Java features and fully aligned with current industry standards. One of the biggest challenges was the comprehensive migration to Jakarta Enterprise Edition 10. The modern application servers like Tomcat 10.1, Jetty 12, and others have moved to Jakarta Enterprise Edition 10. And staying on legacy versions would have meant missing critical security patches, losing vendor support, and accumulating technical debt. With the Spring 6 only supporting Jakarta Enterprise Edition 9 and 10, the namespace migration wasn't optional. It was mandatory. This transition was more than just a simple rename. Back in 2017, when Oracle transferred the Java Enterprise Edition to the Eclipse Foundation, they kept the trademark for the Java X package names that forced Eclipse to migrate all APIs to the new Jakarta namespace, creating a major breaking change in the enterprise Java ecosystem. To put it in context, Java Enterprise Edition 8 in 2019 was the last version using the Java X namespace. Jakarta Enterprise Edition 9 in 2020 introduced Jakarta namespace, and our target, Jakarta Enterprise Edition 10 in 2022, brought the modern features and standards. The migration touched every critical APIs. The Sublet API from Java X to Jakarta, handling all HTTP request, response, filters, and listeners. JTA, the transaction management across distributed systems. JXB for XML binding in cluster configuration, and JCA for connector architecture and data sources, mail for mail notifications, annotation, and CDI for dependency injection and lifecycle management. Migrating to Spring Framework 6 was particularly challenging because it introduced the breaking API changes, but it was absolutely necessary for long-term support. Why upgrade from Spring 5 to 6? Spring 5 was released in October 2020 and its open source support ended in August 2024. It only supports Java Enterprise Edition and the old Java namespace, Java 8 and 21. Security patches in the open source versions are no longer available, and extended commercial support is only available through third-party vendors. Spring 6, on the other hand, requires Jakarta Enterprise Edition 9, 10, and Java 17 or higher. By upgrading to Java Spring 6 with a clean path to 6.2 and beyond, we've secured ongoing security updates compared to staying on an unsupported Spring 5. Essentially, this migration ensures our code base is secure, supported, and aligned with the modern enterprise standard. Migrating to Spring Security 6 required a complete rewrite of the security configuration because Spring Security 6 didn't just deprecate all the configuration API, it removed the key classes and method entirely. In Spring Security 5, we used the Web Security Configure adapter along with Enable Global Method Security annotation and configured HTTP security with the authorized request method and ANT matchers to define access rules. Spring Security 6 removed Web Security Configurer adapter and the old matcher method like ANT matchers and BMC matchers. This forced a migration to security filter chain bean pattern, switching to enable method security, replacing authorize request method with authorize HTTP request, and the modernizing matchers with request matchers. The new configuration also adopted a lambda-based syntax, making security rules more concise and expressive. This modernization touched multiple modules, Web API for REST API security, Web Management for Management API security, and Pulse for UI security, and Geode assembly for integration test configurations. The result is a fully modern, maintainable security layer aligned with latest Spring standard. The Spring Shell migration was arguably the most architecturally significant change in this project. GFSH, GFIsh, Geode command line interface underwent a complete transformation to Spring Shell version 3. This migration was very complex because Spring Shell version 3 is a total rewrite with breaking changes. Components moved from interface-based model to annotation-based. Command discovery was completely redesigned, and the parameter validation framework changed, and the entire tab completion system had to be rebuilt. Annotation changed across the board. CLI command became shell method. CLI option became shell option. CLI availability indicator became shell method availability. And the old shell component interface was replaced with shell component annotation. Core changes included a complete GFIsh parser rewrite for Spring Shell 3 compatibility, a new custom tab completion framework, and fixes for command loading and annotation discovery. Over 118 command classes across multiple modules were updated, including GFIsh for core commands, connectors for JDBC commands, WAN for wide area network replication, and Geode Lucene for search command. Technical challenges solved along the way included parameter validation with custom interceptors, recursive array parameter conversion, Boolean flag parsing, enumerator type conversion, and the reason path handling. The results speak for themselves. In the GFIsh module, all 836 tests passed, 100% success rate. This migration fully modernized our CLI while maintaining complete functionality. The Apache HTTP client library migration was another major modernization effort. It affected how Apache Geode communicates with external systems and manages internal REST operations. I upgraded Apache HTTP client from version 4 to 5 and the HTTP core from version 4 to 5 as well, and added HTTP core 5 H2 to enable HTTP 2 support. This matters because Apache HTTP component 5 is a complete rewrite. It's asynchronous first, supports HTTP 2, has modern SSL or TLS handling, and improved connection pooling and overall better performance and resource management. This required updating modules like Geode management or cluster management REST clients, and Geode connectors for JDBC integration, Geode Pulse for monitoring dashboard, and Geode assembly for integration test. Across 21 files, I was able to migrate all HTTP client code to new APIs, fix the SSL configurations with a new connection manager, updated response and request handling patterns, and resolved redirect and cookie handling issues, ensured everything worked seamlessly with the new library. Apache Lucene is used in Apache Geode to provide full text search capabilities on data stored in Geode regions, enabling fast and efficient text-based queries across distributed in-memory data. I had to fix Lucene index options conflict. I added a point suffix to numeric field names like int point, float point, long point, and so on. And also I had to fix Lucene index command region path, especially formatting. I got rid of leading separators from region path for this migration. And also migrated Apache Lucene components to Spring Shell 3. I had to update the 5 files like create, describe, destroy, list, and search to work with the Spring Shell 3 version. The Jetty upgrade was critical to achieve Jakarta Enterprise Edition 10 compatibility, but it came with significant challenges. I migrated from Jetty 9 to Jetty 12, which included a namespace change from org Eclipse Jetty to org Eclipse Jetty.ee10. Key architectural changes included the handler architecture, moving from handler collection to handler sequence, and the new class loading strategy using the server class pattern to ensure proper isolation between the container and web applications. I also had to address sublet context management, fixing attribute handling with a custom sublet context listener, and resolving Spring jar duplication issues that caused the sublet container initialize failures. Two critical fixes were particularly challenging. First, the class loading conflicts was first. Jakarta sublet API was being loaded from both container and the web class loaders. By configuring it to load exclusively from the container class loader, I had to restore consistent web app first class loading. The second, the SSL endpoint identification. Jetty 12 enforces RFC 6125 compliance, so I had to generate dynamic certificates with a Docker API sans, which allowed all SSL TLS endpoint tests to pass. This migration affected several modules, including Geode Web for core web infrastructure, web management module for the management REST API, and Geode Pulse for monitoring UI. The Tomcat session module introduced the most significant breaking change for end users. In short, I removed support for Tomcat version 6, 7, 8, and 9, which were all based on the old Java X servlet APIs, and added a new module called Geode Modules Tomcat 10, compatible with Jakarta Enterprise and new servlet specification. This was necessary because Tomcat 10 and above use the Jakarta servlet namespace, which is fundamentally incompatible with old Java X APIs. There is no compatibility layer, so we simply cannot support both in the same module. To accommodate this, I made several key implementation changes. I extracted version-specific method into an abstract Delta Session Manager to make a future Tomcat upgrade easier. I also implemented serializable principle, and I cleaned up 27-year-old deprecated sublet version 2.1 APIs, modernizing the module for current standard. For users, this is a hard break. If you are on Tomcat version 6, 7, 8, or 9, you must stay on Apache Geode version 1. There's no upgrade path. If you need Tomcat 10 or 11, you need to upgrade Tomcat. Switch your dependency to Apache Geode module Tomcat 10, upgrade all sublet imports from Java X to Jakarta, and upgrade your manager class in server.xml to Tomcat 10 Delta Session Manager. This is a big bang upgrade rolling upgrades are not supported, at least for the session manager. Looking back on this project, I took away several important lessons, both technical and process related. On the technical side, the biggest lesson was that order matters. I learned that I need to start with the foundational dependencies first, upgrade the build system first, then upgrade the Java development environment, and then Jakarta Enterprise Edition APIs, and then Spring Framework, and leave the application-specific libraries for the last. If that dependency chain is wrong, the entire migration becomes harder than it needs to be. I also learned that updating the test infrastructure is essential. Once the test environment is modernized, I can validate every incremental step instead of failing more than 10,000 cases later. It catches issues early and gives me confidence as I move through larger changes. Another lesson was the importance of incremental migration, breaking huge changes into clean, logical chunks, like separating namespace changes from API behavior changes, kept the work manageable and reduced the chance of introducing regressions. Working module by module, test by test, even using feature flags helped me roll out changes without destabilizing the entire system. On the process side, documentation proved to be far more critical than I initially expected. I had to capture not just what I changed, but why I changed, especially for breaking changes. That documentation ended up being vital for especially reviewers, for users of project, even for my future self. I also learned that backward compatibility has limits. Some breaking changes were simply unavoidable, especially when the underlying ecosystem itself made non-compatible moves. In those cases, I made sure to clearly communicate the impact, outlined migration path when possible, and support all the versions during the transition. And finally, the most important lesson, community engagement. Early communication helps avoid surprises, especially when a project has long-standing users. Getting early feedback, running betas, giving clear deprecation warnings, and offering migration assistance all made a huge difference in smoothing the overall process. The Apache Geode 2.0 project stands as one of the most ambitious modernization efforts in the project history. This wasn't just an upgrade, it was a full-scale transformation. I successfully modernized all major modules, enabled ongoing security updates and patches, upgraded to Java 17 and Jakarta Enterprise Edition 10, revamped the build system, and updated 6 major framework dependencies, and through it all, I maintained 100% test coverage with 0 compilation errors, ensuring Geode remains a viable, modern, and maintainable platform for distributed computing. This project positions Apache Geode for long-term success by aligning it with the latest enterprise standard and security practices. Yes, these changes introduce breaking points for some users, particularly those relying on Tomcat session management, but the benefits of staying current with the Java Enterprise ecosystem far outweigh the migration cost. This is about future-proofing, not just fixing. If you have even a little capacity and would like to pay forward, show kindness, or share your generosity, contributions such as improving documentation, testing, design, or community engagement, not just code, can have a big impact. Sharing the effort ensures we continue fostering a healthy, vibrant, and sustainable collaboration culture in the Apache Geode community. You can go to our website, geode.apache.org, or GitHub, or mailing list, or even check out our event. You can also contact me directly. I have plenty of work to share if you are interested. This release was a huge community effort that reflects the best of the Apache way: collaboration, transparency, and commitment to quality. Thank you everyone who contributed to this milestone release. A huge shout out to Sai and Arnold for their incredibly thoughtful reviews. An extra round of applause for Leon, who jumped in and spotted those critical defects and knocked them out. Thank you all for keeping us moving forward. I understand that contributing to open source often means investing time and energy outside of the workday without immediate tangible reward. It takes passion and commitment. I'm so grateful to everyone who continues to show up. Thank you very much.